Hey guys, so in today's video I'm going to move ahead and solve question 4, right? So after this, after solving question 4, we'll be left only with two more questions, question 5 and question 6, before our exercise ends, right? So let's start with question 4 now, right? So question 4 says that let f be a function of two variables, fx comma y, given by x plus y e to the power minus x plus y square divided by 4, right? So this is our question, x plus y and e to the power minus x plus y square divided by 4, right? And let D be the domain consisting of points x comma y satisfying x plus y greater than equal to 1, y greater than 0, right? So we are given and let the domain D be the point satisfying this, and let D be the domain satisfying let D be the domain consisting of the points x comma y satisfying x plus y greater than equal to 1, comma y greater than equal to 0. A says that draw domain D in the xy plane and find the first order partials of f, and find first order partials of f, right? So basically we need to draw the domain D in the xy plane, right? So domain D, let's just solve this part first. So the domain D, I hope you guys can see. So the domain D is x plus y greater than equal to 1 and y greater than equal to 0. So if I just draw an xy plane, this is the origin. These are all points where x and y are greater than 0, right? So here all of the points are where x and y are greater than 0, and here also y is greater than equal to 0 but x is negative, right? So this is the first quadrant. Here we have positive and positive values, here we have negative and positive, here we have negative comma positive values, here we have negative and negative values, and here we have positive and negative values, where the first coordinate is of x, right? So this is the x sign for the x axis. Sign for the x coordinate would be negative here, right? So this implies x and this implies y. So this implies x, this implies x, this implies y, again this implies x, this implies y, and this implies x and this implies y, right? So now if I just draw, now we have to draw x plus y greater than equal to 1 and y greater than equal to 0. So basically we'll focus on this first quadrant and this second quadrant, right? First, second, this is the third one, and this is the fourth one. So we have to focus on this one and this one, right? So let's just draw our graph now and solve the part A. So these are my two lines. Now this is my, these are my arrows. So this is y and this is x. So x plus y less x plus y greater than equal to 1, x plus y greater than equal to 1. So if I just draw x plus y greater than equal to 1, x plus y greater than equal to 1 comma y greater than equal to 0. So let me just draw x plus y equal to 1. So x plus y equal to 1 is basically this line cuts the axes on 1 comma 1. So if I just try and draw, wait, I can't use this line. I hope you guys can see. So this is 1 and 1, right? This is my x plus y equal to 1 line, right? And also is it possible that x is negative and y is greater than equal to 0 and the sum equals 1, right? It is possible. If x is minus 1 here, if x is minus 1, x is minus 1 and y is equal to 2 and y is equal to 2, then our sum will come out to be equal to 1, right? So now we need to take into account this also, right? So x plus y greater than equal to 1 and x and y I can draw here also. So for this what I can do is all the points lying above 1. So basically these are all points where x and y sum to 1. So if I just take a point minus 1 here, so if I just take a point minus 1, the point that I will be getting on this line will be 2, right? So I'm just showing you guys, if I just put in x plus y equal to 1 and if I just put in the value of x as minus 1, this will give me minus 1 y is equal to 1, so y will come out to be 2, right? So I've already taken into account. Now let me just remove this. The diagram is not that clear, but right, you get the point. Or let me just draw the line again. I don't think this line is sufficing. Right, now you can see. Now this line is x plus y equal to 1. All points above this line, are all those points where x plus y is greater than equal to 1, and obviously because this is this line is lying between first and second quadrant, so y will already be greater than 1. So we'll ignore this part. We'll ignore this part of this line. Why? Why will we ignore this part? Because we need to only account for those values where y is greater than equal to 0. But this line is also extending into the first, second, third, fourth quadrant also. So we'll ignore all these points, right? So let me just draw, let me just rub this off. Let me just rub this line off. So if I just draw and cut this. So sorry. So if I just take my ruler again once more, what I'll do is I'll just draw till here, right? Right. So now we have all the points. We have drawn the domain also, right? So this is the domain D. This consists of the domain D, where my x plus y is greater than equal to 1. All these points are x plus y less than equal to 1. So we won't take this into account. Because if you just take a random point here, if I just take a random point here, this point is equal to half, any point, if I just take a point here half, right? If I just take a point here half, and if I take a point here 2, so 2 will somewhere lie between here. So this point is half comma 2. So if I just add half comma 2, this will be 5 by 2, right? And 5 by 2 is greater than equal to is greater than 1, right? Right? It is greater than 1. So hence all the points lying in this region above this line, and in the first and the second quadrant are required points, or the domain D. So this is the domain D basically, this whole portion. If I just extend this line, so this is the whole portion, right? So now let me just remove this, right? I hope you guys got an idea. I took a lot of time in explaining this concept, which is perhaps very easy, but still I want to take my time and explain all of this, right? So now let's just move on to the B part, which is actually consists of the solving part. Oh wait, we also had to find the first order derivatives, the partial derivatives, right? They asked us for the first order partials of f. So what is the formula for the first order partial for f? For f is del f by del x, right? So we need to find the partial derivative of the function f with respect to x. So this will become the partial derivative of the function f with respect to x. So f of x is, the function given to us is this, x plus y. So we need to find del by del x. The function given to us is x plus y, e to the power minus x plus y square divided by 4. So this will give me this function becomes fx is equal to del by del x. This function is basically x e to the power, or let me just treat y as a constant and solve the whole terms. So using the product rule of differentiation, I'll be solving this. So treating this as the first function and this as the second function. This is my second function, this is my first function, right? So now let me just find. So this will give me 1 into e to the power minus x plus y square divided by 4 plus x plus y e to the power minus x plus y square divided by 4 into, now this will give me minus 1 by 4. This is the partial derivative with respect to x, right? So we had to treat y as a constant. Right? So now if I just take e to the power minus x plus y square by 4 common, I'll be getting 1 minus 1 by 4, right? Oh wait, I'll be getting this x plus y, getting 1 minus x plus y by 4, right? Now if I just try to find y, f of y, which is the first order derivative of the function f with respect to y only, and I'll treat x as a constant, right? So if I just, I hope you guys can see what I'm doing. So I just try and solve this. This will give me, my function is this, right? This is my function. So if I just duplicate this, so again my x plus y is my first function and e to the power minus x plus y square divided by 4 is my second function. So if I just now perform a very basic differentiation, I'll be getting 1 into e to the power minus x plus y square divided by 4, and now I'll be getting x plus y into e to the power minus x plus y square divided by 4 into minus, now the first order derivative of 2y is y square is 2y, so minus 2y by 4 is what I'll be getting. So basically this will become if I just take this e to the power minus x plus y square common, this 2 and 4 gets cancelled. I'll be left with 2 in the denominator. So finally I'll be getting I'm so sorry for the noise that is coming. I think someone is cutting the grass. That's why such loud noise is being created. Right? If I just take this common, I'll be getting 1 minus x plus y into y by 2. Right? Something different. Right? Now we have found the first order derivatives also. Now part B says that take it for granted that f attains a maximum in the domain D, right? Find the maximum point and the maximum point and the maximum value, right? So he's saying that take it for granted that f attains a maximum in the domain D, maximum in the domain D. Now we need to find the maximum point and the maximum value. Find the maximum point and the maximum value right? So now let's just find this, the maximum in the domain D, find the maximum point and the maximum value. So for finding the maximum point and the maximum value, first I would need to check the stationary points and find if they are the interior points also, interior stationary points, and then I'll check on the edge points of the domain, right? So for I have talked about this, I have shown you how I solved these kind of questions in the previous videos, so please check them out first and then come to this video, right? So now what I'll be doing is I'll be equating these first order FOCs with respect equal to 0, so to find the stationary points, right? So what I'll be doing is I'll be just duplicating this. Oh wait, what happened? So now so this will be equated to 0. So this will give me now e can never be 0. E to the power something can never be 0. It can be 0 if your exponent, so for example this e to the power x plus y square divided by 4, this can be 0 if my x and y move to infinity, right? But we are not talking about points where x and y are moving to infinity, right? So now this expression is only left for us to find the stationary points. So this will give me x plus y by 4 equal to 1. So x plus y is equal to 4. This is our first equation. Now I'll use the second expression to find an equation of between stationary points. I'll equate this to 0, right? This partial derivative with respect to y, I'll equate it to 0 to find the second equation. So equating this to 0. Now again this cannot be 0. I mean it can be 0, but then x and y would have to move to infinity, and we are not taking that into account, right? So now 1 minus x plus y into y by 2, this becomes 0, right? So x plus y into y by 2, this becomes equal to 1, right? So finally what we get is xy plus y square is equal to 2. Xy plus y square equals to 2, right? Right. So now this is our second equation. So what I can do is I can find the value of x from this equation. If I just find the value of x from this equation, I'll be getting x is equal to 4 minus y, and I can substitute this expression. I can substitute this expression back into this second equation, right? I can do that. So 4 minus y into y plus y square equals to 2, right? So 4y minus y square plus y square equals to 2, Mm, hmm. My y and y square gets cancelled. I'll be left with 4y equals to 2. So y equals to half, right? Y equals to half. And my x will automatically become, so my x is 4 minus y. So x is 4 minus y. So 4 minus half. 4 minus half gives me 8 minus 1, 7 by 2. 7 by 2. 8 minus 1, 7 by 2. So my x is 7 by 2. So my stationary point becomes 7 by 2 comma half. This is my x star comma y star. But the point is, this is a stationary point, but is it an interior stationary point? So we need to check if this point lies well inside our domain or not. So if I just add 7 by 2 and half, what I'll be getting is 4, right? And y is also greater than equal to 0 here, right? So y is equal to half and half is greater than 0, right? So this point is our interior point because it lies within our domain. So this is our interior stationary point. So this is our interior stationary point. Now we need to check for the domain or need to check for the boundary or the edge conditions. So what I'm given is x plus y greater than equal to 1 and y is greater than equal to 0. So x plus y greater than equal to 1. So what I can do is I can just substitute x plus y as 1 here. Can I do that? I can do that. So the function given to me is, if I just wait a minute, I'm sorry. I'm so sorry, I'm taking my time here. I'm so lazy, I don't want to write this expression again, that's why I'm taking so much time. Just give me a minute. No, I'll write the expression again, sorry. So now, me writing the expression again because I failed to move the whole expression by duplicating the function. So this will give me e power minus x plus y square divided by 4. This was our original question and we were given that x plus y greater than equal to 1 and y is greater than equal to 0. Now we'll substitute the edge. Edge is our x plus y. Edge is our x plus y equal to 1, right? So if I just substitute x plus y equal to 1 here, and if x plus y equals to 1, then y is equal to 1 minus x. So y square will become if I just square y, it will become y square is equal to 1 minus x whole square. 1 minus x whole square, right? So if I just substitute this function here, so x in place of x and 1 minus x in place of y. So this becomes a single variable function now. So if I just substitute x and 1 minus x, this function will become x plus 1 minus x, right? E to the power minus x plus 1 minus x whole square divided by 4, right? So now this will become a function with x only, right? So this will become a single variable function. So I can name this function f(x, 1 minus x) as g of x, a single variable function with only x as the variable. So x and x goes away, so I'll be left with 1 here, e to the power minus x plus 1 minus x whole square divided by 4. Now I can find the first derivative of the function g. So g dash x gives me e to the power minus x plus if I just open this expression 1 minus x square, I'll be getting 1 plus x square minus 2x minus 2x divided by 4, right? And yeah, and if I just find the derivative of this function, I'll be getting minus 1 plus 2 to the power 1 minus x and minus 1 here. Right, so now this becomes g dash x is equal to e to the power minus 1 plus x square minus x divided by 4, and this gives me minus so 2 and minus 2, right? So 1 and minus 2, and this becomes minus 2x plus 2x minus plus 2x. So ultimately this expression becomes this becomes minus 1 minus 1 minus 1 plus 2x, so this becomes 1 minus 2x minus 1 plus 1 minus 2x, right? So if I just remove this, I'll be getting g dash x as e to the power 1 minus 1 plus x square minus 2x divided by 4, or wait, I would also have a 4 here, right? So if I just find the derivative, I'll be left with the 4 here also. So 4 will also come here. Right? 4 will also come here. So I'll be left with this minus 1 plus 1. So 1 minus 2x divided by 4. 1 minus 2x divided by 4, right? If I just equate it to 0 now, if I just equate this function to 0 now I need to find the critical points. For the critical points, what I can do is I can just take this down and I'll be left with 1 plus x square minus x and divided by 4, and this gives me 1 minus 2x divided by 4, right, equals to 0. So this becomes 0 when 1 plus x square minus x divided by 4 moves to infinity, right? But we won't be taking that into account. 1 plus x square minus x divided by 4 moves to infinity when x moves to infinity, right? So this expression 1 plus x square, this expression in the power of e, but in the denominator of the function, this expression 1 plus x square minus x, if I just take this function as h of x and I'll be writing this as x square minus x plus 1, right? So this coefficient with x square is positive, so this coefficient a, let me name it as a, is positive, and if I just try to find the b square minus 4ac value of this expression, I'll be getting 1 minus 4 1 into 1, right? So this will become minus 3 is less than 0. So finding this b square minus 4ac value, the value of the determinant of this expression, shows me that this expression h of x will always be greater than 0. This means that when will this function move to infinity? When x goes to infinity or x goes to minus infinity. But we are not taking into account these values where x is moving to infinity or minus infinity, right? So I'll be just I was just showing you guys why that this expression will always be positive, right? And this expression won't touch or change anything, right? This will always be positive, and this expression will only go on to be 0 when x moves to infinity, right? Now this was not needed, I just showed you guys, right? So 1 minus 2x now, this expression, but this expression can become 0. This expression can very well become 0. So what I can do is I'll be just writing 1 minus 2x divided by 4, and this expression becomes 0. This expression becomes 0 when 1 minus 2x is equal to 0. So x is equal to half. When x is equal to half, this becomes 0. And y was equal to 1 minus x, right? y was equal to 1 minus x, so y will give me 1 minus half. So this becomes half, right? Y is equal to half, right? You can see here, you can very well see here that my y is equal to 1 minus x, right? Y is equal to 1 minus x. I substituted 1 minus x in place of y, right? So this shows me that my x is equal to half and my y is equal to half. Also, this was not needed. We first need to show how the function is changing, at half and half, right? So my first derivative of my original function, this g of x. Oh. So sorry, I deleted it by chance. So this expression g dash x becomes 0 at x is equal to half, right? So if I just find this half, so this will give me negative values. For all values of x greater than half, I'll be getting my function, my first derivative as negative, and this will become positive, right? So this says that at x is equal to half, I am getting a maxima. Yes, I am getting a local maxima at x is equal to half. So now our function half comma half is also a point of concern. So x comma y, half and half is also a point of concern. Is also a point of concern, right? So the 2 points that we have is x is equal to half, y is equal to half, and x is equal to 7 by 2 and y is equal to 1 by 2. Now let's just try to find the values at these points. So first point is x is equal to 7 by 2 comma y is equal to 1 by 2 or 3 by 2. 7 by 2 and 1 by 2. 7 by 2 and 1 by 2. So we just need to find the functional value at these points right here. So at half, so I'll be getting 7 by 2 comma half, this will be x plus y, right? So 7 by 2 plus 1 by 2 and e to the power minus 7 by 2 plus square of 1 by 2 divided by 4. So this will give me 7 plus 1 is 8, 8 divided by 2 is 4, so 4 and this is e to the power minus 7 by 2 plus 1 by 4, 7 by 2 plus 1 by 4. So if I just multiply 7 by 2, it will give me 14, 15 by 4. 7 by 2 plus 1 by 4, 15 by 4. So 15 by 4. 15 by 4 divided by 4. So this will give me basically 4 into e to the power minus 15 by 16, right? So this basically becomes e to the power 4 divided by e to the power minus positive 15 by 16, and we know that e to the power 1 is approximately equal to 2 point something something. So e to the power 15 by 16 will be less than e to the power 1, right? So this will somehow be greater than 1 only, right? Greater than 2 or equal to 2, close to 2 but and greater than 1, right? Close to 2 and greater than 1. 2.8, so 2.2, right? Now we need to find the value of f of half comma half, and this will becomes half and half becomes 1 e to the power minus our second point was x is equal to half comma y is equal to half, and if I just find the values of the function at these points, half comma half, and this will give me half and half will give me 1 e to the power minus half plus 1 by 4, half whole square of half divided by 4. So this will give me ultimately half comma half will become e to the power minus now 4 and 2 3 by 4. So this becomes 2 plus 1 3 by 4 divided by 4. So this will become e to the power multiplied by 1 by 4. So this will become e to the power minus 3 by 16. E to the power minus 3 by 16. Right, so we can clearly see that e to the power 4 into e to the power minus 15 by 16 is obviously greater than e to the power minus 3 by 16, right? Right, so my x comma y, which is 7 by 2 comma half, is the point of maxima, and 4 e to the power minus 15 by 16 is the maximum value, right? So this was our fourth question. Now let me just check my answer and see if what we did was right or not. I hope you guys were able to see. I was not, I was just solving the question below. I was not communicating well enough in this video, right? So I don't know if you guys were able to see my working here clearly, but I hope you guys were able to, right? So let's just check our answer once. Let's just check our answer. Let me see. Now you can clearly see that the answer to the fourth question which we just solved, right? So the answer to the fourth question which we just solved was this, right? The fourth question says that the first order partial derivatives are this, right? First order partial derivatives are this. So e to the power minus 1 by 4x plus y square, and this was our expression, and the partial derivative with respect to y was this, and the point 7 by 2 comma half gives us the maximum value for e to the power minus 15 by 16, right? So I hope you guys got what I wanted to share with you guys in this video, right? So if you like the video, do share the video with your peers. Also do like the video, put a comment, and subscribe the channel, and I'll hope to see you in the next video, right? So bye bye. And I'll also put the PDF of my working in the description so that you guys can revisit, or if you guys find any errors in my working, please let me know, right? So thank you.